In this video, we're going to talk about congruence mappings. So we talked about congruent triangles and congruent figures in the last section. And this section kind of ties together the discussion about congruence and pairs it up with what we've talked about previously about rotational symmetry, reflectional symmetry, and then even ties into tessellations. But all of those then kind of lead us into the next section, which is kind of like the big finale for the chapter, which is talking about similarities between figures. Okay, now I do want to mention two things before I kind of get going in this video. First, there's kind of a bit of drawing, so I do refer to some problems in the book. If you have trouble drawing them, you can kind of write that information down and then refer to the book for your notes. If you do try to draw them, I would go ahead and maybe get some graph paper. I think that would be useful. I'll do some drawings, and some I might actually pull from the book, but we'll just kind of see what happens and go with what happens. Okay, so for congruence mappings, there are three basic congruence maps we're going to look at. There's what's called the translation, which we'll give it a plural, translations for translation mappings. So this is a mapping that can be described as a sliding motion. That is a sliding motion. So if you were to literally have physically a figure that you moved, the figure itself, where you moved it to, doesn't change. And that's a congruence translation. Okay, it's a mapping translation. So let me go ahead and give like kind of a simple example of that. So let's say I have this line segment. We'll call it line segment AB. Okay. And I want to move this line segment, physically move this. All right. So the way I'm going to do that is I'm going to kind of slide the line segment along this diagonal here. And if I draw it well, it'll hopefully look exactly the same. All right, there we go. And so the idea is this is the moved line segment. So to indicate that I have moved this line segment, I'm going to introduce this notation where, oh, here, sorry, it's a little bit close. Shift up a bit. There we go. And then B with that little, like, it's like a dash. It's not a one, and it's not a power. That particular notation, let me just put it down, is read A prime. So in math, we use that little marker to indicate something that is connected to something we called A. So A prime, okay? So it's supposed to be that we're connecting it to the original AB line segment by referring to it as A prime, B prime. So we understand that what we have done is taken line segment AB and have moved it. And by moving it, we've changed its location. So we gave it a new name. All right. That is how we can kind of use some notation to show the sliding motion. All right. So I am going to kind of do a rough sketch here of number 2 on page 831. And I'm going to access my graph paper or graphing background here. Okay, to kind of do this the best I can. So if you do look at the book, sorry, I apologize for coughing. If you do look at the book, and if you're trying to draw something like this for your homework, right, this can be kind of the way you do it. So I'm going to just basically create like a little, almost like an XY axis here. Oops. And use the squares to indicate the dots that they have on the page. Okay, so I'm going to use the dots on the bottom. So this would be the start of that figure at G. And then this would be F. And then it looks like they go up here to E. And then up here is H. And then it looks like they go up again to I. All right, and then it looks like they have a box here. Oops. I don't know why I care so much about that specific one, but I did. Okay. And then we'll call that one D and J. All right. And then above, they have this indicator that they want us to move. Let's see, it would start on the fourth one. So one, two, three, four. Okay. So they're wanting us to move this figure. I'm using the dots to kind of help me with this. So they're wanting us to move the figure up 2 and over 3. So here, let me give it a new color like they did. So the result is that they want me to shift this figure with this motion. That's my terrible dashed line. Okay. So to do that, basically I'm going to take each dot, each corner, and I'm going to follow that pattern of going up 2 over 3. And I am kind of using the coordinate plane to help me do this from what we talked about before, just to help me be able to draw this on the page. Okay, so up 2 over 3. So this is, I'm redrawing J right now. Okay, for D, if I go up 2 over 3, here would be D. And then E, I, H, and G, and then F. Okay, now I'm not going to be able to draw all of the letters. Oh, it's so bad, that dot. Let me fix it. There we go. It's just too big. Oops. But that's okay. I'll go ahead and indicate what I can. So this would be I prime, H prime. I had to really can't put a G prime. It's a little too close, or F and E. It's a little bit too close, but there we go. So you can kind of see that I moved the green figure over, and that allowed me to kind of show where it moved from the original using the mapping pattern that they had with the new notation. In fact, I probably should, just for the sake of having the answer there, go ahead and erase those and go ahead and call this G prime. This corner one here is F prime, and then this one is E prime. All right, squeezing them in there. And there you go. Okay. Let's try here. Let me just make a simple one up. All right. For this one, I'll kind of try to make it a little bit easier. I'll do it myself. My own little picture here. Okay. So I'm going to kind of make 5 by 5 if I can here. Let's see. 1, 2, 3, 4, 5. 3, 4, 5. Okay, so if that hopefully makes it a little easier for you. All right, and then here, I'm going to go ahead and draw my initial figure to be, oops, at those two ordered pairs, and then like this. So I'm kind of just drawing a simple trapezoid. All right, and I would like to translate this. I'm going to use a verbal description for right and 5 down. Okay, so basically what I'm going to do is I'm going to take each point, right, just like I did above, and I'm going to go right 4, 5 down. Okay, so for like this top point here, I'm going to go right 4 and then 5 down. So that's going to land me right there. Let me go and put a red dot there. And then I could basically just redraw the figure at this point without going to each point and going right 4 down 5. I mean, you can, that's fine, but there would be the translated figure. Okay, so there's translations. Rotations, it's the next mapping that we're going to look at. So for rotations, we need to have a center of rotation. Oops, sorry, I bumped the screen. So we need a center of rotation. So something has to be what we're going to rotate about. Okay. Like we have to have that in order to do any sort of rotation. Let me give an example. I'm going to kind of do, again, another simplistic one of my own drawings here. Make a little coordinate plane. All right. And here, I'm going to draw a triangle. I'm going to start at, if you're thinking of it as a coordinate plane, -1, 2. And then I'm going to go out to -4, 1. And then I'm going to go up all the way up to -4, 4. All right, so there is my triangle. And here's what I'd like to do. I want to rotate 90 degrees clockwise about the origin. So my rotation is right there. The origin is going to serve as my rotation. And I do want to go ahead and take a sec and actually write out what those ordered pairs were that I just gave you. So I said that this ordered pair is at -1, 2. This top or this bottom ordered pair is at 1, 2, 3, 4. Yeah, -4, 1. And this ordered pair is at -4, 4. All right. So if I'm going to rotate this 90 degrees about the origin, the idea is I'm trying to make a 90-degree angle. I'm going to draw a really bad version of the angle, and then I'm going to do a good job. Okay. So here, I'm trying to get that, right? Like that kind of a thing going, a 90-degree rotation. So if I were to measure with my protractor, it's going to go about 90 degrees. Here's the nice way to do that. If I'm working with and these ordered pairs, what I basically do is swap the X and Y values. So 2, 1, and I graph that here in the first quadrant. Okay. I'm going to do that with the next ones. So that would be 1, 4. And then 4, 4 would be the last one. And what I have done, and I'll draw it, is I recreated the triangle, and this angle between them is 90 degrees. Okay. So I'm going to write down these ordered pairs. So I've swapped the X and Y values, and then I went into positives because I was moving into the first quadrant here. So this one was 1, 4. That doesn't look like a 1, but I'm going to try to make it look like a 1. There we go. 1, 4. Okay, so that's how we can kind of move it in or in a coordinate plane. Okay. I want to look at another one from the book. I want to look at number 6, and this is on page 832. This one again kind of uses the grid point method again. And same idea, they want to do a 90 degrees rotation. Okay. So I'm going to create a grid for this. Oops. Wow. Doing a terrible job. Drawing straight lines. All right, there we go. And I'm actually going to go by 2s on this one just because of how tight it was to draw that number 2 up at the top there. So I'm going to kind of think of it as these are the tick marks. All right. For imitating what I'm seeing in the book. Okay. The figure itself is actually in the corner. All right. It would be at the origin starting at 0, 0. And then it's going up 1. And then it's going out 1. And then over here, it's going out 2. So this would be a mimic of the figure they have drawn. Okay. This would be E. This one would be D, G, and F. Okay. I'm also going to write the ordered pairs here. because I'm going to try to use that to help me do the 90-degree rotation. All right, as best I can. I don't know if I really can with the way that O is set up. Actually, I take that back. I may not bother. I do need to plot O really quick. Okay, so O would be at 1, 2, 3, 4, and 1. Okay, 4, 1. Here it is. Okay, so here's O. Did I do that right? 1, 2, 3. Nope, it's too far. I did 5. There's the rotation point. And we want to rotate it 90 degrees. Huh, interesting. They actually recommend using a piece of paper to do this. And that could then allow you to use a protractor to do it, to trace it on a piece of paper so you could map it out. I'm going to do my best to freehand this, okay? So what I'm doing is I'm going to take the point F, and I'm going to rotate it about 90 degrees. Okay, I'm gonna say that it's probably close to somewhere like that. So I'm feeling like we would go from the point F to the origin. We went up 2 over 4. So I'm going to kind of follow that. 2 over 4. Sorry, I'm trying to. It might actually be. Might actually be more like this. I'm sorry. There we go. Maybe that's a little bit closer to what it should be. Okay. And let's try doing that with G as well. Actually, here, I want to do E since I'm trying to follow this. And of course, here's where it gets a little bit challenging. It's not going to fall quite on the lines because of the way the rotating works. Okay, so if that's E, I'm going to guess that D, oops, it's probably a little bigger. D would probably be somewhere over here, and G would be somewhere over here. And this is why they recommend you get a paper to rotate it. All right, I kind of did that visually. May not be perfect, all right, but I feel like it's not terrible in terms of getting us, oops, sorry, that was supposed to be E, not D. So this is E prime, F prime, G prime, D prime. All right, so I kind of tried to reproduce that quadrilateral there at a 90-degree angle. Not bad. But if you did have a paper, you would do a better job of that than I just did instead of trying to freehand it. All right. You get the idea. They're not easy. Some of them are challenging, and you really will probably want to grab a picture from the book or create, like I said, this kind of coordinate plane on some graph paper. Okay. The last of these mappings is reflection. And I think this one's actually probably the nicest out of them. So for this one, you will need a line, or if you're doing a 3D figure, a plane. Sorry, I meant to say or a plane. To reflect across. All right. We'll again try something basic to do it. This will be my made up example here. We'll just stick with quadrilaterals. They're not doing us too badly right now, are they? Okay. And let's go ahead and make our figure start at 0, 1. Then we'll go about 4 out, 3 up, here and here. All right, there we go. All right, so this, I want to reflect across the x-axis. And if you remember, the x-axis is the horizontal one here. That's the x-axis. So I want to reflect it across the x-axis, which basically means I'm wanting to mimic this shape across the x-axis, and it'll look like a mirror image, so it'll look upside down. And there you go. Okay, that one wasn't too terrible. And that's kind of reflection actually is probably the easiest of the three. Okay, now last thing they want to do is they do want to connect these translations and mappings to a specific type of tessellation. And it's called the Escher type tessellation. Escher type tessellation. Okay, I'm going to get rid of the grid background here for myself. I don't really need that right now. And it's a little distracting for me as I'm drawing these. Okay, so the Escher type translation, or Escher type tessellation uses these three basic mappings to kind of help us create a tessellation. So typically what it does is they start off with like a basic picture. Okay, so here, I'm going to demonstrate a translation tessellation. All right, so here's how it would look. We start with a figure that's pretty easy to work with. I'm going to do my best to draw a square here. All right, so there's my square. Okay, here's the idea. I'm going to cut out or draw a new, I guess I'd think of it as cutting out. I'm going to cut out just a simple kind of arc in this bottom here. All right. And I'm going to cut that out like visually, maybe if I'm thinking of this as a square piece of paper, and then I'm going to move it up to the top here. Oops. Darn it. There we go. All right. I didn't mean to get rid of the line. All right. So I'm trying to mimic it. Wow. I can't seem to get the perfect length. All right. You know what? I'm over it. Okay. And the idea is that creates this kind of figure that's different and kind of unique and could be tessellated. We can get more exciting with it. I could then take this side here and maybe kind of do a cutout inward like this. All right. And then think of cutting out on the other side like this. So I'm going to move that mapping over here. Oops. Try that bottom one a little bit more pronounced. And what I then have is this. And what's kind of cool about it is it's an interesting figure, something kind of unique and different that could be tessellated because it's supposed to be perfectly matched sides and they'd all fit together like little puzzles. All right. And it all comes from the original, I'll just kind of redraw that original square back in that we are making these cuts out of. All right. That was not the perfect version of that square. Sorry. Tried to do it again. There we go. All right. Making those cuts out of. Okay. So they can do this with rotations. Let's try a rotation now. A little more challenging. And I'll try to do a basic one so I don't make it difficult. Like you would think that what I just did up there wasn't that difficult, but man, I struggled. Okay, here, let me get, there's a misspelling. There should be two L's. All right, great. Feeling better about myself. All right, I'm going to go ahead and try to draw a hexagon here. And I'm going to make the sides equal if I can. Fix that, make that a little less pronounced. All right, best I could. There we go, fine. All right, same idea. I'm gonna take and pull out or cut, right? Like this, and then I'm gonna extend this. All right, and I'm gonna rotate it and repeat, cutting out this and extending this. And then you cut out this and you extend this. And I'm trying my best to make it in the middle of the page where I'm cutting out, quote unquote. Oops. And extending this. Cutting out here. Extending down here. Last one. Cutting out here and extending down here. And the idea is if I can carefully erase what was left in blue, which I'll do for you, all right? But you don't need to. The idea is that the green is representing the new tessellated piece, and the blue is from the old one. I'm gonna try to erase the blue here. Okay. I knew I was going to do that. Try that again. Oops. I'll go ahead and just redraw that. All right, and there's what the tessellated piece would look like. And because you're supposed to have done it perfectly and you cut out the same piece everywhere, you could tessellate this figure over and over and over again. I'm gonna actually put the original back because that's what you'll have on your page. All right, and then lastly, we have the reflection tessellation. So this one uses reflection instead on the figure. This one I'm going to draw kind of like a nice rhombus if I can, or diamond shape as best I can. All right. Trying to pretend those are perfectly equal. And I'm going to take out pieces. All right. So let's say I take out a very small curve here and then do a triangle out here. Great. Well, I'm going to mimic that with symmetry on the other side. Small curve, triangle. And I'm going to try to mimic that here at the bottom. I'm going to do small curve, a little bigger. Small curve, triangle. Oops. Wow, that got really sloppy really fast, didn't it? Okay, small curve and triangle. All right, and the idea is what's left, the shape that's left, I'll try my best not to erase the green, is supposed to be this kind of crazy symmetrical shape that's really crappy looking, but can be tessellated. All right, and there's the idea behind the Escher type tessellations. I encourage you look at the book's pictures. They're quite beautiful, but really you're going to be more identifying whether or not there's a reflection or a translation in the tessellations themselves.